Yep.
Yes.
Cool. Take it away.
Perfect. All right, folks, thanks for joining. Good morning, bom dia, and this will be our third webinar in the series, so AI for non-programmers and applicability for the target sectors. So I'll just start by talking about intelligence itself. Our ruler that we use for measuring intelligence, it tends to be actually very simple and biased if you think about it. We basically just think that, you know, the closest to human behavior something can get, the more intelligent it is, right? So we normally think as the chimp as a very smart animal, but the fly as a very dumb animal. Even though flies, if you think about it, they have a lot of intelligence, they have swarm behavior, all this different stuff. But our ruler is a little bit biased. So these behaviors that we call intelligence, they can be summarized in some core skills, right? So first one will be interacting with the surroundings. So touching, hearing, seeing, moving, all these different ways that we interact with the surroundings. Reasoning, which would be like making decisions, planning, remembering stuff, having like memory. And also discovering, which is using previous experience and like new experimentation to get to something new, right? So when we talk about artificial intelligence, it makes sense that we will consider like something, a technology, artificial intelligence, if it resembles some of these traits, right? Some of these core skills. In fact, AI is still a very fuzzy and very often overstretched concept. So it's very hard to define like exactly what is AI. But one thing that is important to distinguish is AGI, which would be artificial general intelligence. So these will be actual like superhuman capabilities, and we are still not there. And narrow AI, which is task-specific, problem-specific AI. So this is already well developed, and this is kind of what we're going to cover here today. So different methods on narrow AI, right? Some people consider that we are seeing some like initial sparks of AGI in the newest deep learning stuff. For example, ChatGPT and these large language models, which is like intelligence, artificial intelligence that is starting to kind of just discover stuff, extrapolate from the original data to come up to new conclusions. Okay, so AI itself would be better described as a set of different technologies, right? So this is just like a short list, it's not an exhaustive list, but if you think it as like a bigger umbrella with all these different technologies under it, we would have like smart sensors, computer vision, robotics, text-to-speech, and the other way around, and also machine learning, which is, let's say, the core technology here in AI. And within machine learning, we have different like learning paradigms as well. I'm going to cover basically the three that I've mentioned here in the presentation as well. So we can see that all these different technologies, they kind of cover those traits that I was mentioning before. So interacting with the surroundings, remembering stuff, trying to make decisions. So these will be the technologies that actually enable these bigger technology, which is AI. Okay, but why should we learn how to use AI, right? So I'm gonna do like a parallel with other technology, which is the internet. So can you imagine nowadays, like a medical doctor who can't use the internet, or a lawyer or politician, engineer, right? It's very unthinkable. But these professions, they have been around for thousands of years, but the internet, which is only like 30 years old, has completely changed them, right? So we believe that AI will have a similar impact in the next few years in many different professions as well. So at the same time, everybody uses the internet nowadays, but we don't need all to be IT specialists, right? We are all users of this very complex technology, but we don't need to be like the people that develop this technology. So this is why I believe it's also increasingly important to know AI from the user perspective, and knowing the problems that it can solve, the limitations, where it will work very well, where it will fail, some medical considerations, all this different stuff that we kind of learned throughout the years about the internet. But still, and the same happened like at the beginning with the internet and with like computers. Normally, at the beginning of the popularization of technology, all the training, the courses, they come from the developer perspective, right? So this is why I wanted to put together something that was AI for non-programmers, so people can navigate, and know a little bit better what these things can solve without knowing how to put them together. So what we're going to cover here today, we'll focus on the core technology for AI, which is machine learning, right? So machine learning is this set of computational methods, and it has also become this large research field. So in machine learning, we have algorithms that are not explicitly programmed to do something. The way we work is that we give data to these algorithms, and they learn models from this vast amount of data. Okay, it can be considered the key enabling technology for AI because basically that's how all the AI solutions learn from data. Okay. So we're going to cover some important terminology here. So I'll start with models and modeling, right? So a model will be just a simpler representation of a real world like object, process, phenomenon, basically anything that you need to model, okay? Because it's a simplification, they are all wrong, right, to some extent, but many are still useful. So this is a famous phrase from a mathematician, Box. He's huge into like financial forecast and stuff like that. So he used to say, all models are wrong, but some of them are still useful. Models can vary on a very important feature, which is how easy it is to understand how they work, right? So for example, what we call black box models would have no interpretability. So it will give us a response, an output, but we don't know how it got there, okay? And if you think about it, models and modeling are very familiar to us as humans. We just don't notice this, right? So I'll ask you to, take a look in this short clip here and think, why is this so surprising, right? But if you think about it, we have probably never seen like a balloon dog hit a cactus before, but we have our own model of what would happen, right? So even though we have this model, we are actually not solving like any physics equation, thinking very hard or trying to predict what's going on with the balloon. We just know that, it's floating, so it should be something light. It looks like a balloon and stuff like that. So we can say that our inner model that we carry for gravity and physics around us on Earth, it's a black box model, right? So we don't know exactly the rules that we use to reach a conclusion, but the conclusion is pretty reliable to us because basically we can navigate around our world with no problems, okay? So the next terminology topic that I want to cover is soft computing. So I'll start by asking you guys to imagine a very simple experiment. So for example, flipping a coin, right? So you flip it and you take note of the outcome. You will agree with me that getting 3 consecutive heads or tails is not very unlikely, right? So this is actually like a doodle. If you go to Google and ask like flip a coin, something like this will show up and you can actually flip a virtual coin on Google. However, when we do this kind of stuff, we don't expect, for example, to get 10,000 consecutive heads or tails, right? If we flip it 10,000 times. So now imagine that you guys have to model this experiment, right? So it will be a model that would take a flip as the input and will return the outcome. It's a head or tail, okay? So a traditional way of doing it, or the analytical approach, would be to analyze the object, right? So we would take the coin, we will see, okay, this coin has only 2 sides, so it's only 50% of chances for each of the outcomes, right? So that's straightforward enough. So another approach would be to flip the coins, let's say 10,000 times. And as we know it, we don't get 10,000 times the same outcome probably, right? So let's say that we do it and we get 5,050 heads and 4,950 tails. Okay, so we take note and then we do it again a few more times. So until we get like hundreds of thousands of flips, okay? Then at the end, we propose a model. So both heads and tails from this coin have a 50% plus or minus 1% of chances to be the outcome, okay? So when we think about a computer program, like the traditional way we develop computer programs, we normally will relate it to something like the first approach, right? It would be an analytical, closed, exact way of doing things. So we can call this way of doing computing hard computing, okay? On the other hand, when we have methods that will allow for some uncertainty, some imprecision, or approximations to solve given problems, we call it soft computing methods, okay? So these will be more kind of related to our second approach to the modeling of the coin flipping. Okay, because the coin is such a simple object with only two sides, it's very easy to, do the analytical way, see, explore the features and see, okay, it's just a simple object. It only has two possible sides, so it's only 50% each. So it would not make sense to use the second approach in this case. But soft computing is especially useful when we are trying to model something that is very complex, which is hard to see the features, like the characteristics, but we have a lot of data generated from whatever it is, an object, a process, or anything that you're trying to model. So for example, we will probably never get like a precise formula for predicting the risk of cancer in someone, but we can analyze data from millions of patients and try to identify some, common characteristics on these patients and try to estimate the risk, okay? Another thing that I want to tell you is about convergence. So when we are talking about the flipping coin experiment, when we perform it for a large enough number of repetitions, naturally the proportion of heads and tails will tend to converge to the 50% each, right? So this is what we expect. So this behavior is well known and very explored in statistics. And most of the machine learning techniques, they use this property, right? And I ask you guys to notice here that instead of saying that we are calculating a result like we normally do with, let's say, traditional programming and traditional problem solving, let's say, we say that we are converging to a solution, okay? Sometimes we even not, we may not even achieve a convergence. So depending on the data that we have or the random initial conditions that we use. So basically some of these techniques, they need to start from random conditions. And if you pick like the wrong ones, you may never achieve a convergence. Okay, so let's talk about the machine learning methods and the types of problems that they can solve. Okay, so the different ways of learning. So I would define the machine learning methods as the cutting edge of both statistical models and computational resources combined, right? So it's nice to see that, like, coming from the statistical side, many of these approaches, they've been around for like 100 years or something. It's just that now we have the computational power to run them in a like useful way. So starting with supervised learning. So we use it when we're dealing with labeled data, okay? So this is when we have a set of predictors or features, as we call them, and we are trying to use these predictors to get an outcome or to predict an outcome, which will be the target, okay? So we normally split our data into training and test subsets to avoid overfitting. So overfitting happens when I'm training a model using some data, and then my model gets really good in that specific data set. But when I test it with any other data that it has never seen before, the model fails very badly. Okay, so this will be overfitting to my training data. So the most common problems that we use supervised learning for are regression and classification. So starting with regression, in regression, we are using qualitative and quantitative data to predict what is a strictly quantitative outcome, okay? So we are using data to predict a number, okay? So one example here that I give you is, could we predict fuel consumption on cars given their horsepower, for example? So let's say that all of these like small dots here, they are different cars in my training data set. and I will try to come up with a model that will, try to explain the relationship between horsepower and miles per gallon in this case, so fuel consumption. And we can see that this relationship can be linear, so sometimes this relationship is better explained by just a simple line, but sometimes we need non-linear models as well. So we need something that is more curvy, more wiggly, so a model that is more flexible to actually, model the true relationship. We could also do multiple regressions. So this is when I include more than one predictor. So for example, if I want to estimate someone's income using their level of education and seniority as well. So here I would have like income in my y-axis, let's say, and then I would have the years of education here and seniority here, and all the red dots would be my like data points, the training data, and my model itself would be this plane here, right? So what we do with these methods is try to get as close as possible to the training data with this huge plane here. One thing to notice here is that level of education could be just a qualitative predictor, right? So it could be only like high school, college degree, postgrad degree. So we can see that we use numbers and just categorical data to predict a number which is income. So we can do it with regression. Now, talking about classification problems, they are similar, but in this case, we are using, once again, qualitative and quantitative data to predict a strictly qualitative outcome, which would be a class, right? So this is why we call it classification. So for example, what's the probability of somebody defaulting on their credit card given their balance, right? So something like these. And then I could include more variables. So if they are a student or not as well. If include their income, if they are the level of education. So we could use all these different features to try to predict if somebody is going to default or not. So the way we do here in this specific case is we get a model for the probability, right? From 0 to 1, so 0 to 100%. And then by choosing a threshold, so let's say 50%, if this probability is above 50%, our outcome will be default. If it's less than 50%, the outcome will be not default, okay? So this will be one approach for solving classification problems. This is also extendable to multi-class problems, right? Not only binary classification. So binary is when we have only two outcomes. So for example, if we have a set of symptoms, if we had blood pressure, weight, age, and wage from a patient, is someone more likely to be having like a stroke, epileptic seizure, or drug overdose, right? So these are three different classes. And if you think about it, there's no kind of logical order between them, right? There's no scale. Because, for example, when we're talking about level of education, even though it's like just different categories, but we could put like an order, like high school, college degree, postgrad degree, this kind of stuff, but not in this case. So when we're dealing with problems like this, classification is what you need. Okay, there will be also different types of models that we can use to fit this data and to solve these problems. So we can divide them between parametric or non-parametric, right? So this will be basically asking the question, do we want the model to follow a specific structure, so a given formula that we know and that we kind of see what's going on and interpret, or can they try to fit the data freely, using simple rules? For example, just looking at neighboring observations to make a decision on the data that you want, for example, on the specific observation that you want. So usually using parametric methods will lead you to more interpretable results and more interpretable models. Okay, so now let's talk about unsupervised learning. So when we use unsupervised learning, we also have the same predictors or features, right? But there is no target to be predicted. So we're not trying to model or predict anything. We are actually trying to find this underlying pattern or any informative way to visualize these data. So the first type of problems that we normally use unsupervised learning is clustering problems. So this is when we need to group some data in different subgroups that will show some similarities. So for example here, Facebook might want to group the users based on their interests. So for example, sports people, cat people, political people, given their interest, they will put you inside like little boxes. So this way they will sell better target, they can like target ads for you in a better way. So they can, offer this service to whoever's paying to Facebook to get advertisements there. So notice that in this case, there's no ground truth, right? There's no labels in my data. So there's also no clear right answer, right? So there is no clear like right way of doing the same thing always. So the results in this case, they normally need to be validated by expert knowledge. So somebody would see the subgroups and they would say, okay, that makes sense, or this doesn't make sense. Let's try once again. Another thing that we do with unsupervised learning is reducing dimensions in data, right? So a common problem when you're dealing with large data sets is selecting the most relevant features, right? So it would be either to use them in a model or just to see the data, just to visualize the data. So dimensionality reduction methods, they are used for both these tasks. So the idea here is just to find a simpler representation of a given data set that will still carry most of the relevant information, right? So in a way, we're kind of filtering out the noise from this data that we have. So I always like to give this example here, which is kind of the same idea. So when you have like a 3D object, like a house, and you are drawing the floor plans, let's say in 2D, you are reducing the dimensions, right? You're going from 3D to 2D, but you're keeping most of the useful information, right? So you can still basically do everything that you need, like regarding understanding how the house looks just by looking at the 2D projections. So imagine that you could do the same thing with basically every type of data. So textual data, numbers, basically anything could have something like this. Okay, so our third learning paradigm will be reinforcement learning. So these are normally used when we have agent-based problems. So an agent that will learn how to navigate a surrounding, or will learn some specific rules to solve a problem. So for example, if we had an autonomous race car, which would be the agent, learning to drive on a new circuit. So the reinforcement here would be, it will get rewarded if it keeps within the track and lowers the lap time, right? And it would be penalized if it goes off the track and loses time. So we have two systems, one to reward and one to penalize. So what happens is that as we give like the successive rewards and penalties, this will eventually lead to a good strategy, right? So this would give me a model good enough to navigate that specific track. So the same idea could be extended to many problems that can be summarized as a search for a set of rules or a strategy, right? So this would be what we call heuristics. There is a very like large research field as well in these types of problems, which is evolutionary computation. This is my area of research as well in my PhD. It takes inspiration from the Darwin's theory of evolution to search for solutions for a given problem. So we use the same idea of survival of the fittest to try like a population of solutions, change them a little bit at every generation until we converge to a very good solution. Basically, because nowadays, as I was mentioning, we have the computational power to test, let's say, thousands of solutions for a given problem very quickly. So we can afford to use to solutions like this and like get to results very fast. Okay, we have seen all the main types of problems that machine learning can address, all the different types of learning. And for each type, we have many algorithms and methods that can be used, right? So I won't cover the methods here. As I told you, this is like a very, let's say, high level introduction to AI. Don't want to go into the programming side of it, but there's there's a specific class of methods that has been widely used with huge success in many of these learning areas that I wanted to cover in more details, which is artificial neural networks. Okay. Neural networks are, in fact, not a new idea or not a new technology. They were introduced in the 1940s, so it's a very old idea. And they are based on a simple mathematical model for the actual biological neurons, right? So the idea here is that it's very hard to understand how a whole brain works, right? But it's very easy to model how a single neuron works, right? So this will be like the biological neuron, and this will be the mathematical model that kind of does the same thing. So the neurons, they kind of talk to each other using these dendrites. Then we have a core here where all these different stimuli are kind of processed. And then depending on whatever came, into these little antennas, it will basically pass the information on or just hold it. So it's exciting or inhibiting the axon terminals. So that's basically what this model here does, like using mathematical terms. Okay, so we have a threshold. If we have like enough stimuli in the inputs on the summing junction, then if it reaches a threshold, we're gonna, let's say, output 1 or 0 in the output of the neuron. Okay, it's a very simple concept, but just like, for example, a transistor can scale if you use millions of them to a processor, right, inside your computer, the same thing happens with neural networks. Okay, so if we scale this thing up and they were refined, like these little model here got a little bit more complex with some like new research. But if you scale a very simple cell like this into a big neural network, then you have a very powerful problem solver. Okay, so this will be what a neural network looks like. So we have hidden layers, we have like input layer, we have output layer, and this is how it will interact with the world. So it takes inputs, process whatever is there, and then give you outputs. So as I mentioned, these networks are a very powerful machine learning method, and they can solve many of those types of problems that I was covering there. So reinforcement learning, supervised learning. Nowadays, we know like the different topologies and which ones are good for each types of problems. And to see just like how powerful it is, a network with a single hidden layer can approximate any continuous function. And a network with at least 2 hidden layers can approximate any function. So this is very powerful. So the hidden layers will be the number of layers within the inputs and outputs. So we can see that something like this can already approximate any function. So this is a very powerful method. And that brings us to deep learning as well. So neural networks are also the base for deep learning. So it's the same idea of using multiple neurons and layers. But when we're talking about deep learning, we're going to a much bigger scales, right? So basically many neurons and many layers. So we would have a huge network like that. Deep learning is actually behind most of the impressive results in AI in the last few years. So for example, self-driving cars, fraud detection, like for credit card companies and stuff like that. Natural language processing, so your Alexa and the likes of it. Visual recognition, large language models, so ChatGPT and all these big, like impressive AI solutions, they will very probably be based on deep learning. Deep learning has, as I was mentioned, has also been used in most of the generative AI applications. So generative AI is those systems that will generate an output. So for example, image or text when you give it a prompt, right? So the hottest topic nowadays would be the GPT models, right? For text and image. So ChatGPT, Stable Diffusion, DALL-E, all these different generative AI solutions. But GPT stands for Generative Pre-trained Transformer. So generative basically will create new things for you. Pre-trained is you don't need to like train this model. You don't need to run data through it. It's already pre-trained by Google, OpenAI, Amazon, whatever. And transformer is just the type of neural network. So this is just a type of neural network which has improved memory, right? So it keeps coherency with a sequential context, because the first models of this type, if they had to, for example, generate long phrases, they would kind of forget what they were saying at the beginning and kind of lose track and start saying things that don't make sense. While transformers, they use a concept called attention, which actually enables them to, show very big text and, create images and stuff like that. So just some quick examples on how this technology works. So this here, I gave a prompt, generate a rabbit with wheels and frog skin, and we can see that it does a very impressive job in generating exactly what you want, even though it's something that makes no sense at all, right? So this is Stable Diffusion, one of the generative AI solutions that you can find online for free. This is ChatGPT. So I've asked ChatGPT to explain, what it is, what is a large language model. And you can see that it does a very good job. So a large language model is an artificial intelligence algorithm that is trained on vast amounts of text data to understand and generate human-like language. So that's basically what we can do with ChatGPT. But talking about large language models, they are trained in vast amounts of textual data. So for example, the whole Wikipedia and some other internet forums. But at the end of the day, what they do is just text prediction, right? So let's say, for example, that you start with Liverpool is the best. So if you search around the internet, right, the whole internet, what is the most likely word that comes next? So let's say that 54% of the times would be team, right? So Liverpool is the best team. 32% of the times would be Liverpool is the best city, right? And you would have all this rank of different like probabilities of the next words until something that like makes no sense at all. Let's say kebab, 0.001%. So once, sometime, this phrase was, on the internet, somebody told it, Liverpool is the best kebab. It makes no sense. So the probability here is very low, right? Then the next one, okay, what if team was the chosen word? Then the next one will be, let's say, 22% in the world is the best team in the world. It's the best team in England, all the way down until, once again, something that makes no sense. Duck, I don't know, a random word, right? So what ChatGPT is doing, what large language models is basically this bit here, but very well done. So we have loads of data behind it. We have loads of computational power behind it, and they have perfected the way they're doing this thing here. Okay, so how did they get so good? How they can kind of fool us that they actually are like artificial intelligence or general artificial intelligence? Basically, because we are using now unprecedented large models, right? Right. So we are training hundreds of billions of parameters inside these networks. We are also using huge, huge amounts of data. So for training these networks. So nowadays we're kind of using the whole internet, just feeding these models with the whole textual data in the internet. And also we have loads of computational power. So it's only like big players training these models. So Google, Facebook, Amazon, all these other giants in what we're calling now the arms race on AI, right? And this is raising a lot of red flags as well. So how can they go bad, right? So why are people so kind of worried about these models? The first like obvious thing would be like disinformation, right? So like every other model, we have this say that garbage in, garbage out. So if you're using bad data, your model will give you bad outputs. Okay, and bad data has different meanings. So for example, because these models are so large, they take like a few weeks or months to train, right? So for example, if you ask ChatGPT 3, I think, today, what's going on in Ukraine? It will say, oh, no, nothing. Ukraine is great. Basically, because the data set that is there at the moment will be from, let's say, 2021 or 2020, right? So everything that is more recent, you wouldn't know, right? So this is something that you always need to be aware of, the time scale of your training data set. The other thing is that most of places have no regulation, like no countries would have regulations in place nowadays to basically deal with this powerful technology. So this will raise all the different ethical issues, unfair competitive advantages for these big techs. So many different problems could come from it. Next one, also, what if these AIs get out of their sandbox, right? So can you imagine like the first ever AI generated malware or the first ever like AI generated computer virus? If they are so smart, how bad it would be for us. So that's something that we should consider as well. The other thing, it's like a philosophical question here, is the alignment problem. So, okay, in case you achieve AGI, so superhuman AI, will its goals be aligned to humanity wants? So will this AI want the same thing as we want? So there's a very clear example to understand this bit is, okay, if we get, let's say, in 5 years to this superhuman intelligence, and we ask them, okay, how do we solve climate change? If it's aligned to us, it would say, okay, stop using fossil fuels, try to use renewable energy and stuff like that. If it's not aligned, it would be just kill every human on Earth, right? Because we are causing climate change. So if you want to fix climate change, you just get rid of humans. And this is kind of the same idea of the butterfly or cockroach kind of dilemma here. So how would this super intelligence see humans? So let's say that we get this AGI, which has an IQ of, let's say, 5,000. The average human has the IQ of around 100. It's kind of the same gap between humans and, let's say, a butterfly and a cockroach. But when we see a cockroach, we want to step on it, we want to kill it, right? But when we see a butterfly, we're, oh, that's a nice butterfly, that's a beautiful insect, right? So how would the AI see us, as a cockroach or as a butterfly? So this is another question that we have to ask. Okay, so this brings another kind of set of ethical considerations in AI, not only for deep learning specific, not only for large language models, because we have actually seen a number of these ethical issues with AI recently. So some examples here, face recognition fading with non-white people. So basically they were training models without using, images from non-white people, so it won't work with non-white people. So there was a hospital screening system that was not recommending intensive care to some patients that were very ill, because they were very likely to die anyway. So this system was kind of trying to optimize the intensive care unit usage. So given the symptoms, the history of the patients, they would say, okay, send this one to the intensive care, or keep this one in the bed. So because it was trying to solve a problem, which is, okay, how we handle the limited resources of intensive care beds. So if the model was kind of predicting that somebody was very likely to die, they wouldn't send it to the ICU, because the people were gonna die anyway. So let's keep that bed to somebody that is more likely to survive. We had Google Photos tagging Black people as gorillas a few years ago. We are seeing some copyright issues with AI-generated music covers in the last few days, like people are using these like deep fake and stuff like that to do different music covers between artists, and they're not very happy about it. And also some other intellectual property discussions about, for example, ChatGPT using code, like program code that people have posted online. Now some of these large language models, they are reading this code and like offering a paid service, for example, as a co-pilot style thing. So, okay, when I've posted this code there, I didn't know that it would be, eventually used as a revenue stream for a given company, right? So this is kind of another ethical discussion as well that is going on. But these are just some like kind of obvious example, right? So these are clear examples, but many silent ones potentially exist as well. So for example, uh, banks, they will use these models to calculate risk when giving loans to people, right? So how risky it is to give money to somebody, uh, if they are going to pay back or not, right? So let's say that your postcode would be one of these features that they use to predict your risk, right? So if you're coming from a very poor area, you're probably less likely to get a loan, right? Because your risk is higher, you're coming from a poor area, so you're less likely to pay back the loan in full. So then you are less likely to afford, let's say, a college degree or open a new business because you cannot get this initial money to, basically invest in yourself and, go up the social scale, basically. So this vicious feedback loop, it will keep happening under the hood because basically they will just trust blindly whatever the algorithm is telling you, right? Given the risk, if it's high or low, even without knowing how it's getting there, right? So it just keeps like this feedback loop. Because you're poor, you can get a loan. Because you can get a loan, just keep being poor, basically. So to fix some of these problems, we should avoid some bad practices when we are, implementing these systems. So one first bad practice is just use black box approaches for everything, right? So interpretable models are easier to audit, to understand, and to improve. So I can see where it's failing, and I can see why it's failing, and I can make it better. The other one is choosing biased data sets. So that's something that we shouldn't do as well. Especially when we're dealing with human beings, we should keep our data set as diverse as possible, right? So I want my training data to basically accommodate every diversity of, different people that I can find. The other bad practice would be accuracy at any cost, right? So if you sometimes when we are training a model, the model that will have the best accuracy, maybe just modeling real world biases, right? So we should have fairness as another objective that is as important as accuracy in some applications, right? So you must take care that you're not just modeling bias or hard coding, real world biases as well. Okay, now a little bit on the applicability of these AI solutions in both the sectors, construction and textile sectors. So I believe we could split them in two types, so related and non-related to the end product. So not related, we would have like many different ways of using AI. So basically every step of the manufacturing process would generate data that could be modeled and assist the decision-making stage, right? So digital twins, we have cyber physical systems, basically every like a production stage generates data. We could model this data. We could predict stuff. We could make decisions based on this data. The other one would be kind of, let's say, in the office kind of environment. We're seeing now these co-pilot style assistants. They are already a reality in many office software. So for example, Microsoft is about to introduce generative AI in its products. So for example, if I was putting together this presentation, I could open PowerPoint and say, show me some applicabilities of AI in construction and textile. And it would kind of suggest for me some bullet points, based in a generative AI. So this is the kind of stuff that is about to get released by Microsoft. I think Bing already uses the search engine from Microsoft already uses ChatGPT style suggestions. Now, related to the end product, right? So of construction and textiles, the first one that came to my mind was, okay, generative AI can be a very powerful tool when we are developing and prototyping new products in both sectors, right? So you could, how I asked for a rabbit with frog skin, so you can ask this very crazy stuff, and the AI will try to put something together that at least will give you like a starting point and an iteration to next version of your product. Also, evolutionary computation, as I told you, this is my area of research. So I know that it has been used before for optimizing constraints such as like weight, structural rigidity, and cost in the construction sector. So for example, many of the CAD solutions, the computer-aided design solutions, nowadays they would incorporate some AI that will kind of generate for you these organic looking structures which are optimal for a given constraint, let's say weight or structural rigidity, or two of them at the same time. And so this would be another use for AI. The other one would be the use of smart sensors to gather lifetime usage data. So once you sell your product, you are monitoring that product through the whole lifetime. And then you can use this information to feed the next iteration of that same product with some insights, right? So let's say if you're measuring how like temperature, air quality, basically any kind of measure that you want to take from a house, how the house kind of behaves in a given situation, and how you could make it better, like if you're building a next house, next suite, for example. So yeah, this is another application as well. So to wrap it up with some recommended reading, this one here is a book that is available for free if you want to Google it. It's Machine Learning for Humans, from these two guys here, Manny and Sabri. These will be kind of what I have covered here today, but talking about the methods as well, right? So we will talk about all the different learning paradigms and the types of problems that we can solve with this within each of these learning paradigms, but also the methods that we use to solve each one of them. Even but this one is still not going to the programming side of things. It's just basically like an overview. This one is a very famous book on the ethical considerations of AI. So it's called Weapons of Math Destruction by Cathy O'Neill. And it will talk about all those vicious feedback loops that I was mentioning. Like she worked for many different companies in big data, like financial, this kind of stuff. So she has a lot of experience on when these things go bad, basically. Yeah, so that's it. This is our IDM cluster website on LinkedIn if you want to reach us. And now to the discussion, I will just leave a question here for the discussion if you guys think that AI is opportunity or threat for your specific sector. Yeah, thank you. Go back here.
Thanks very much, Samuel. Very interesting presentation. What's your suggestion? Do you think it's a threat or an opportunity?
To be honest, I'm quite worried with the new stuff that is showing up. Like we had this open letter from many researchers, like high-profile researchers, saying that we should stop training these large language models for a few months to put regulation in place, basically, because it became just an arms race. So it just like the companies competing against each other to see, whoever gets the best one, without actually thinking too much about the consequences. So what I believe is the biggest threat is that thing that I was mentioning. What will happen when we get the first AI-generated malware, the first AI-generated computer virus? How this thing will spread, in a much efficient way than every other virus that we have seen so far. But yeah, narrow AI, like use it within the boundaries that it should be used. I think it's a big opportunity for many different sectors.
Okay, thanks. We were proposing to have a couple of small breakouts just to make it easier for people to discuss the question.
Can I have a question to all?
If there's any question first, maybe bring that in. And Samuel, you're still sharing, or I'm seeing you sharing both your screen and...
Oh, yeah. Thank you.
Yeah, you can. Yeah, perfect.
Vladimir, you have a question?
Yeah, Vladimir, please.
Yeah. Do you hear me?
Yeah.
Yes.
Okay. I'm thinking on this recent events in Serbia where kids killed the other kids, and they learn about that on the internet. There is so much of that bad stuff there. And Samuel was talking on learning that these models are learning from internet. So internet is full of, let's say, bad things, which are should be considered ethically, regulatory sense. If they learn from that, and if this is not regulated, human being can do that. How this learning of bad stuff from the internet can be a problem.
Yeah, I think it's a very valid point, and even a concern for me around learning from the internet is that what we're learning from, these models are learning from today, is by and large content that has been put on the internet by people, and it represents good and bad knowledge that we have. There's predictions that within 5 years, 80% of the content on the internet will have been automatically generated by the artificial intelligence and software bots. So the actual valid source material will become a small part of what's on the internet, and the AI will be giving us answers based on what other AI have created, which is, and if anything, what we know from history is that the pace of that change always happens much faster than is predicted. So if in 5 years it's predicted to have 5 times of today's content on the internet generated by software, then it's probably likely to exceed that by multiples. So I think we will all be looking for some sort of verification or proof of truth in whether it's a browser we use or a tool we buy, or even our news feed. And there is a role there for regulation, but I think we've proven with the internet that it's impossible to regulate, really. The government moves too slowly, and that the companies who are in this for profit will continue to work that way.
Yeah, they're just their objective is just like maximize profit, and with this type of like algorithms, this type of AI, it can go very bad, because they do what they're told to do. So I was talking with Camila the other day about a specific like AI competition that happens in a conference that I normally attend, which is generating robots that can walk, right? So these are like a simulation, and the robot can get like more, let's say, longer arms or longer legs, and it kind of builds itself and it walks. Okay, so they measure how far this model, this robot has walked in the simulation, and they give it a score, right? And they measure using the head of the robot as the reference. So, okay, people come up with loads of different strategies to make my robot walk, as long as possible. But then one of the guys just let like AI try to find the better solution. And like while all the other robots were walking like 100 meters, 200 meters, this guy was walking like 1 kilometer. So they were like, okay, that's really impressive. Like this is an AI finding a much better solution. So they went to check the robot. The robot was just like 1 kilometer tall, and it would just fall into this phase. But because they're measuring, the reference point is the head of the robot, it would fall 1 kilometer away from the starting point. So it was winning the competition, but in a very unpractical way. So when we let these AI algorithms that are trying to maximize or minimize something kind of work by themselves, they can find very strange solutions, right? So if, like John was mentioning, in 5 years' time, the AI is running and reading from itself to generate new stuff, this can potentially amplify bad things so much that is even scary to think about it. So yeah, you have a good point there, Vladimir.
There is another example. There is another example of that where an AI was trained to do a relatively simple but time-consuming assembly task as a robot, and then having mastered the process to do that, the AI was asked to teach another robot how to do the same task. And within a few minutes, the first runs took longer than it took the humans to program the robot. But in later iterations, the AI created a new communication language between the two AIs and massively sped up the process of training the other robot to the point where the people in the experiment pulled the plugs on the power because the AIs had taught themselves a faster way to communicate that was unreadable or could not be understood by the programmers who were in charge of the experiment. So yeah, the potential for that. Camilla, you want to come in?
I have a question.
Yep.
How do you think we can use, because we're using, even though we're not conscious about it on our mobiles, how do you think we can use it in a safe way? Like, should we be more critical when taking on those tools or the AI? I don't know. It's hard to control because it's kind of everywhere. But it's just to have like this critical sense of.
Yeah. Samuel,
yeah.
I'll come in and just I think there's one critical thing, and it's very relevant with the large language modules or models. That is, if you submit information into ChatGPT, for example, you have no idea who you have given that to or what access they have to that. So if you have your list of your clients in your organization, your customers, and you want to design a marketing campaign, a very simple thing to do in ChatGPT, all of the information you've provided, you have given it away, and you have given it away without rights. So there was a financial analyst in London asked ChatGPT to analyze their stock portfolio of all of their customers. So that entire information base. So when you submit information into these prompts, you no longer own that information, and you're providing it into the owners, OpenAI, for them to use as they will. So that's the first thing I would caution for anyone, is if you have sensitive or private data, then you don't put that into these open models. Okay, Samuel.
Yeah, no, that makes sense. It kind of, in both ways, you should always be like, don't trust blindly, like when you send stuff and when you receive stuff, because there's loads. Like if you go to YouTube, you see many people like poking around ChatGPT to see where it fails, and sometimes it will give you like very unreliable answers, right? So my biggest like advice would be, don't use it to like important stuff. Basically, it's very good to substitute your first Google search, right? But don't go beyond that yet. So for example, if I wanted to know, let's say, the different types of birds in Ireland, right? I could go to Google and say, what are the different types of birds in Ireland? Then it would show me like, I don't know, maybe 10 more relevant pages. I would open each one of them. I would see, okay, no, there's this one here. Yeah, there's the, magpie or the The other ones, okay, fine. I would have my bullet point, my list. If I ask the same thing for ChatGPT, it would give me kind of the same thing. It's as if it went there to this first 10 pages and, you know, compile this bullet list for me. But now if I ask further saying, okay, now give me a detailed, let's say, history of, you know, biological, you know, overview of the different birds in Ireland, then it will start making up things, right? So you will say, oh yeah, the magpies, they came, I don't know, they migrated from South Africa. It will just start spitting stuff that may not make sense. Okay. So yeah.
It's about to inputs that you put on them, then you get the outputs.
Yeah.
So you need to be careful also with the inputs that we put in. Okay,
Yeah.
cool.
And the other thing as well, these are what we call stochastic methods, right? So basically, every time you use the same inputs, you are not guaranteed to have the same output, okay? Because, you know, as I was mentioning, many of these models, they start from a random initial condition to achieve a result, to converge to a result. So the same happens with ChatGPT, for example. If me and you, we ask the same thing, maybe wording it in a different way, we're going to get different answers. And one of them could be wrong, or, you know, one of them could be partially right with a bit wrong, and then the other way around. So yeah, it's my first advice would be don't trust it blindly. Always double check, use it for, you know, just high level stuff. Don't ask for deep information because it's not a reliable source of information.
Okay, guys, thank you so much.
Okay.
Can I have one comparison? For example, you know, in construction, engineers use a lot of software to design the building, the structure. But there is a sort of engineering knowledge behind, you know. You pass the school, the studies, and there is many, you know, knowledge you generated, and you have, you know, backup for the outcome of the software in your knowledge. And actually anybody can design the building nowadays, you know. The same software can be used by anybody, but without the knowledge behind, it's useless. A stupid mistake can be done, and this is just software. So how this artificial intelligence tools, you know, even we don't have that backup, and we are engineers, you know. So what about I don't know, less educated common people, or us engineers in some other field we are not familiar with, you know?
I think it's that's the big part of the risk. I mean, for example, if you have a particular political persuasion in the US to follow the Republican Party, and you use the information in your browser that you normally have to look for information as to whether Donald Trump is a good person or not, you will find a lot of very credible material saying he has saved the world. And if you believe, you know, if you're disposed to believing that, then that's what you will view, and that's what you'll have on your social media feed, on your, you know, Twitter, and you will be exposed to all of the people who believe the same thing. If you put the question into ChatGPT, if Donald Trump is a good person, you'll get that he saved the world one day, and the next day they'll say he should be in jail, often linked to how you ask the question. So I think we live in this world where now anybody can do things, but yeah, where the verification of this lies, I believe we've crossed that tipping point where people believe what they see on the internet. Yeah. And AI can now generate very believable content, which may not be true, and is often very biased by the kind of questions you ask and your profile and your background, in asking the question. So it should come with a very strong warning as to how you use it. And I think what's really important is you should always know that if you're getting an answer that's been generated by an AI, then that should be clear. Whether the screen changes color or there's a red bar or there should be a health warning or something like that.
Yes.
Yeah.
So here is again comparison with structural software. You have the same challenge or the task, and you use the same software with the same data, you have always the same result. Now in artificial intelligence, this result can be different from day to day.
Yeah.
One day is that, and the next day is something else. Maybe in 2 hours is different. So this is not reliable tool.
Yeah, and me and John, we've worked before with some projects with medtech companies, and because it's such a regulated industry, they already have some like regulation in place regarding this kind of stuff. Basically, because you like you were mentioning all these stochastic methods that would always give you different results. They are very strict on what they allow or not to be inside a production line, right? Regarding AI. But like John was telling about like all this, we call the echo chamber effect, which is basically what social media, what it's trying to maximize is the time you spend there, browsing, scrolling through your feed. So you always try to catch your attention with new videos, new, I don't know, news articles, all these different things. So the tendency is the tendency of convergence there is to basically just make people more radical in views that they already have. Like, so as John was mentioning, if I start Googling about Trump or any other political view or something like this, it will start suggesting me new stuff that it's only going deeper and deeper and deeper and more like narrowed into a specific worldview. So yeah, this is kind of the same idea that I've covered about algorithms that are very accurate but are not very fair, right? So if Facebook has an algorithm that will keep you, let's say, to increase your screen time by, let's say, 500% in average, this will be probably a very damaging algorithm, socially speaking, because it will basically just radicalize you or, will make you be like very focused on a specific topic, for example. So they have ways of, balancing things out, saying, okay, we want some let's say to increase screen time, but we also want to increase diversity, right? So every now and then you're gonna see something that is completely unrelated to the stuff that you already like or that you already follow. So these are very easy to implement. It's just not on their interest because you cannot sell target ads to these people that are kind of like everything. So
Okay, and any other questions from the audience? I think we're probably coming to the end. So
yeah, there's some literature about different. The generators. I think you've posted there, John, don't you?
Yeah. So somebody asked there about some follow-up information on the AI generator. So there's two there, I suppose. One is the AI generator, the art generators, like the frog with the wheels. So I think some of them are very, very good, really, really good, and create very nice imagery, and it's quite interesting to play with how you ask the questions and what they produce. You can change existing photographs or create new content, and that's quite nice. And the large language modules, that's just it's a listing of assessments of some of their sort of veracity for the kind of top 7 or 8. So the links to each of them are there, and if you want to see, there's some comparison between them. And for industry, we've just started to look at these maturity models. So for digitalization in manufacturing, we use digital maturity assessments as a first start with companies, and that covers essentially where they are, a benchmark, what are the important areas of digital transformation and even sustainability within the industry, and what is the roadmap based on metrics to get value from digitalization. So these AI maturity assessment models also exist for different business models or different types of companies, as to whether what you do will, AI is applicable, and what type maybe of AI, generative AI hybrid models that link engineering information with co-piloting and so on. So there's a number of those quite valid ones there. You'll see some are linked to well-known research organizations. So I think there's a good starting point for anyone with a company or an enterprise on the call. And yeah, I see Samuel has added the links to the books also there.
Yeah, I've posted the one that I've mentioned, the machine learning for humans. It's quite a nice one. It's short. It's like 97 pages.
Okay.
And it covers, it won't go into generative AI yet because it's a bit like from 2017 or so, but it will cover like the basics in a broader way very, very nicely. And then you could go into something more specific like generative AI. But yeah, it's a very good one.
Cool. So last chance if anyone else has a question before we bring the webinar to a close. And maybe Camilla, do you want to just mention the open calls again and what people need to do or where they need to go to get the funding support for innovation?
Yes, the calls are open. The deadline 7th of June. So I'll just pop the link here as well on the chat. Yeah.
So has anyone got any question while Camilla's just doing that? Okay. Yeah, okay, we're wrapping up. In my own experience, the use of the likes of ChatGPT, particularly 4, is really excellent at accessing large quantities of information if you provide it with 30 PDFs of white papers or information and ask it to summarize the key points in 4 lines. It's really good. It'll do it better than I can do it, and it'll do it in a much shorter period of time. I know people are using the software generation parts of it. The coding part is very good, but you need the expert analysis to fix the coding at the end, typically. So it's a good help in the workflow. But just yesterday, I was on a call where somebody was trying to use it in one of our core domains is around industrial automation, programmable logic controllers, and someone who had spent their weekend trying to get it to help write code in that area, which is quite narrow and quite specific, found it no use whatsoever. So
yeah,
that's yeah. So there's opportunities there and there are threats, and I suppose understanding it better is what we're trying to help people with. And I would say pilot it, try some applications, find use cases maybe where it can be of help. Okay. Okay, any final comments for anyone? We're good to go.
I want to say thank you to you and Sam. Thank you so much for putting the webinar together for us.
Thank you.
And we invite everyone to join the next one on the 24th of June.
Of May?
Of May, sorry.
Yeah.
And that's on the topic of... earlier.
Data-driven decision making.
Yes.
If I'm not wrong.
Excellent. Yeah. Data-driven decision making in manufacturing. Okay.
Yeah.
Okay, thanks to everyone for joining the call today, and we hope we'll see you again on the next one. Good luck and thanks.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye.